Have you ever stopped to consider the difference between a model and a simulation? This question might sound a bit abstract, but once we unpack it, you'll see it's quite practical. You see, a model is a simplified representation of a system. It's like a map, a distilled version of reality that highlights the features we care about most. For instance, a spreadsheet that calculates the growth of your savings account over time is a model. It takes into account your initial deposit, your monthly contributions, and the interest rate to provide you with a clear picture of your financial future. On the other hand, a simulation is a bit more dynamic. It uses a model to mimic the behavior of the system over time. It's like taking that map and going on a journey, seeing how the landscape changes as you traverse it. So while both models and simulations are tools to understand complex systems, they do so in different ways. Let's delve a little deeper into the world of models. Models can be as simple or as complex as the systems they represent. Consider something as straightforward as forecasting sales. By inputting previous data into a spreadsheet, we can create a model that predicts future sales trends. Or think about calculating the trajectory of a projectile. With a few physics equations and some initial conditions, we can create a model that tells us exactly where that projectile will land. These models are deterministic. That means, given the same inputs, they'll always spit out the same results. It's like baking a cake. If you follow the same recipe with the same ingredients, you'll always get the same cake. But what happens when the system we're trying to model isn't so predictable? What if there are too many variables or the rules aren't so clear-cut? Models are powerful tools, but they can't capture the dynamic and unpredictable nature of many systems. That's where simulations come in. Now imagine a situation where the outcome isn't predictable, like the spread of a disease or the behavior of a stock market. This is where the power of simulations comes into play. Simulations allow us to model these complex stochastic systems, where outcomes can vary widely based on a multitude of factors. Unlike straightforward models that you might solve on a spreadsheet, simulations often require more sophisticated tools. You might need to write your own software or utilize specialized programs to create a robust simulation. But why go through all this trouble? Well, simulations can provide crucial insights into the behavior of a system under different conditions. They allow us to experiment, to tweak variables, and to observe the potential outcomes. This can be invaluable in decision-making, particularly in fields where the stakes are high and the variables many. In conclusion, while models give us a simplified representation of a system, simulations allow us to explore the dynamic behavior of the system in a controlled manner.